Simon is the Chief Executive Officer and founder of the LX Group. Simon is was part of a BRW Fast 100 company specialising in IoT product and solution development. Working with technology startups through to multinationals for 10 years, Simon and the team at LX have worked on over 200 custom IoT products and projects, straddling a wide range of technologies and industry verticals. Leveraging this experience in the IoT product development, Simon has led the technology architecture of LX IoT Cores, an IoT platform spin-out from LX Group with the goal of dramatically lowering time to value for those looking to develop IoT products or solutions from base stations through to wearables. Please welcome Simon.
Thank you. I don't usually sound like an adult call line. I had an operation on my vocal cords 1 week ago, so bear with the voice. I've been doing a little bit of survey whether it sounds sexy or creepy. Most people are saying creepy, so sorry about that. Okay, so for 10 years we've been building Internet of Things devices. They weren't called that. Back then it was mesh networks, it was M2M, it was telematics, telemetry. But that's what we specialise in, ultra-low power wireless devices. So we've been doing this for a long time. It's got a really cool name now, the Internet of Things. But for a long time, we've been using shovels to go on and dig for Internet of Things opportunities in the Internet of Things gold rush, if you like. And what I mean by that is, like, we take a long time to build a custom electronic Internet of Things product, and it costs a lot of money, and you eventually get something. But what we've done, about a year or two ago, we started a project that's very, very exciting, and we're very excited by it. We've gone from the shovels and we've built a machine for building Internet of Things products. We can crank out Internet of Things products now in a way that I don't think many people probably can around the world. We actually did a global study of everything that was going on about it, a year and a half ago when it came to IT hardware. But let me explain the problem that we're solving. So hardware is hard. A lot of people have probably heard that. Investors are scared of hardware. And a classic example is Fitbit, $7.8 billion success story. Nearly failed 7 times because of hardware. With the predictions along the lines of 50 billion IoT connected devices by 2020, what's different to the waves we've seen before? So the first generation of the computing wave, where you had a computer and you've got people writing software for it, and you've now got a smartphone, the second generation of the computing wave, and people writing apps for it. Those two things bred an army of software developers around the world, right? So to start a company, to build value, you get a software team, you build an app, you go and market it, you sell it, that's it. But the hardware is something that people already have, or it's something that already exists. There's only a few platforms, and someone's done that hard work. But if you look at a company like Fitbit, you've got the app, but then you've got this thing. You've got a bit of hardware that you've got to produce somehow. Now, that's what we're solving. That's what we're making really easy. We're making the hardware component very easy. In a nutshell, like, the race for verticals is on. What we're seeing, especially in smart cities, but in a lot of areas, is it's a physical real estate grab. If you're the guy who does all of the telephone poles or all of the bins, and then someone comes out 3 years later with a better product, you're sticky. You're very sticky. Because someone's got to do a truck roll to go and replace all the product in those bins or on those streets. So it is a physical real estate grab. And we are seeing people scrambling for this, but they're falling over when it comes to hardware. They go and spend a year or two building some hardware, and then some of them have homing pigeons that comes back. So what our IoT cores are designed to do is allow people wanting to go and tackle an IoT opportunity to start 10 metres from the finish line in the 100-metre sprint. So hardware is holding a lot of people back. It's a real barrier to innovation. It's a little bit like, in order to build an app, people are building the iPhone first, if that makes sense. So just to understand a little bit of what we have done here, it's good to look at why the computer and smartphone took off. When the computer first came out, it was big, it was expensive, it didn't do much, and it cost a lot. When those 4 things were solved, we all got one. They went nuts, everyone got computers. Same with the smartphone. If you remember the bag phone the big clunky bag phones, really power hungry, didn't do much. They'd make a phone call, but that was about it. When those four things were solved, smartphones went nuts around the world. We all got smartphones. That's all we're seeing with the Internet of Things. That's the trend. The Internet of Things has been around for 20 years. You know, we've been monitoring pipes and things, but 20 years ago, it might have been a big $100,000 shed outside a pipeline going across Australia to just measure one thing like pressure or something, right? So what's happening now is, just as you saw with Peter, with Honeybee, we're getting to the point where sensors could be sprinkled around the world. We're instrumenting the physical universe because we're able to. And the data we can get is just phenomenal, and it's useful. So we found that this need for custom hardware was coming thicker and faster every day. And people had shorter time frames. They had sometimes smaller budgets. And so you look at some of the prototyping technologies like Arduino, BeagleBone, Raspberry Pi, Intel Edison. These technologies use a stacking methodology that if you were to actually build something that you need, it often ends up being big, quite expensive, and power hungry, and it doesn't always do what you want it to do. It also has other problems, like a lot of these things, if you put them on a street pole, they won't last in the thermal extremes that you need them to work in. If it's a Canada, for example, with a really low temperature, or sometimes just a normal environment like this. So we actually tried to use some of these technologies to do some quick and dirty stuff, but they weren't right. And a lot of them you definitely can't scale with. So we said, what would be the ultimate IoT hardware utopia? What would be the ultimate thing? We came to the conclusion that it would be like a little pill. This little pill would have all the sensors that you would ever need on it. It would have all the communications interfaces that you would ever need. And it would be able to draw power from the environment, or to be able to draw power from what's ever available. And a little bit like in an iPhone, there's an accelerometer. So you can write an app for your iPhone to become a spirit level. You would just then be able to write an application for this thing and get going straight away. But there's one other component, and that would be the enclosure. So you would have to build some kind of enclosure to go around this thing. It would just have what you need. You wouldn't have to use what you don't need. It'd be ultra low cost. And it's just all about, maybe if branding is important to you, then building an enclosure around it. Now, we didn't get to the size of a little pill, but we got pretty close. This is our biggest core. It's 19.5 mils wide. It's long because we did an analysis of over 400 different IoT verticals to come up with this technology architecture. And how it works is, instead of stacking, we're using ultra-dense technology to make a bit of hardware that has a whole heap of onboard sensors, a whole heap of wired sensor interfaces. It can be powered from solar, from inductive charge, from non-rechargeable batteries. It can communicate on Sigfox, on LoRa, on the mobile networks, Wi-Fi, Bluetooth. And what you do is, instead of stacking these things together, you just cut and slice the board where you don't need things. And you don't populate what is not needed, right? This is very commercial hardware. It's not something you can prototype with this and then go and scale very quickly. So our vision, a part of our vision is, imagine if, at the moment, someone has an idea. They can probably print an enclosure for their idea in the next day or two. But then they wait a year for some custom hardware, or they end up with something big that won't even fit in it. Our vision is we could maybe create and accelerate innovation by printing something, and then actually throwing a core into it and enabling it on the internet, being able to do everything you want it to be able to do with it. Now, what we did to accelerate these things, because we think the cores look cool, but talking about cores is a little bit like talking about an Intel processor, an Intel chip. It means stuff to us, but a lot of people don't care. They care about the computer that it's in. So we did a range of base stations, sensors, tracking devices, and wearables. These enclosures that the cores go into, just to get people going really quickly. But often, for the commercial products we're working on, a custom enclosure is always part of the project. So let me give you a very quick case study. This is the world's smallest dog tracker. It has Wi-Fi, Bluetooth, it has 3G, GPS, low poly charge management. If you were to build this using Arduino, your prototype for your user testing, for your trials, for your government grant, for your venture capital raising fund would look a little bit like that. Consume so much power as well that you would have a battery about that big. If you used one of our cores, it would be that big. It would consume nearly no power. I mean, the same amount of power as this. It would be at a cost that you can scale today in the same way that this could. You just have to wrap an enclosure around it. So that is essentially what we've done. Now, when it comes to smart cities, there was this great iPad campaign a few years ago where you're trying to look at how do you explain what an iPad is. And this ad was saying, iPad is your recipe book, iPad is your gaming center, iPad is your email client, it's your video player, it's everything. It's what you want it to be. Well, these are projects that we're either working on currently, we worked on previously, or they're just kicking off right now in the smart city space that are using the technology that we've used or some predecessors of it. Smart rubbish collection, some intelligent transport, some optimization of school bus routes, smart parking, infrastructure monitoring, big things, smaller things, the inside of the things, like air quality, poles. But then you get down to things that are just forgotten, things that maybe before were commercially not even able to monitor in terms of when you need to go back there. Similarly with transport and logistics, you got things like trucks. Trucks have been connected for a long time. But now we're not just connecting the trucks, we're connecting a container, not just a container, but the pallet and the boxes within them. And then things like shopping trolleys, things that you wouldn't have even previously imagined connecting. Bikes, even power tools, or maybe the guy using the power tools. Smart homes, we're doing a lot of stuff in smart homes, including looking at things like solar panel efficiency. Solar, there's a lot of monitoring system for solar, but there's a lot of older stuff out there that people have spent a lot of money on solar installations and you don't realise that 1 out of the 8 panels is not working, so they might be losing a few $100 a year, or leaves or something, getting on top of the panels. The tanks, I took your point, yeah, the tanks. Even the termites. Do you have termites around your home? At the moment, if you have a termite inspection system, we paid at our place, we live at Hornsby Heights, we paid, I don't know what it was, like $500 for a termite monitoring station. This thing was a block of wood with a bit of water dropping on it. And that's it. But the thing about this block of wood is it is particularly tasty. It's like a lamb rack or something for termites. It's good wood. And part of this service is that a guy comes out 3 times a year, I think, to have a look to see if there are termites in the block of wood. Your dog, connect to your dog. Emergencies, so there's some stuff that we've done in emergencies as well for letting people know in their home. Marine, and not just the harbours, but also the boats within them. And of course, you get to the point where you just start looking at mapping and connecting everything. So only 10 minutes, I'll wrap up. But what are IoT cores? They make it remarkably easy to connect any sensor via any wireless link to any cloud using any power source for any application, from base stations to wearables. Essentially, our IoT cores, they build the things, the physical things. They make it easy so you've got an API to connect to, so that the software developers in our wonderful world are now back at home. They're back plugging into an API and they're happy. So yeah, essentially we've spent years preparing for your IoT product launch so you don't have to. And we released the IoT Cores website only 2 days ago, so go and check it out. Thanks very much. And thanks for putting up with the voice.